Hello, everybody. As we continue on our journey in organic chemistry, today we will be discussing structural isomers, and I'm going to give you a real quick introduction to the organic functional groups. So please take out Table R. I will be referencing that after my isomer discussion. Okay, here is the definition of structural isomers. First of all, they all contain the same molecular formula, but they have different actual structures. And because their structures are different, they will behave differently chemically. So, a classic example would be butane. The structural isomers for butane. The first example here is N-butane, and I haven't used this term with you before, but anytime you have a straight chain version of a hydrocarbon, it's going to be called the N version, which is N-butane or normal butane, okay? The structural isomer here for butane would be what we call isobutane, and you'll see that we have the exact same number of carbons and same number of hydrogens, therefore the same molecular formula, but it's a different structure. And because of that, these would be considered structural isomers, which, by the way, you would not be expected to know isobutane as a name or a naming scheme for Regents chemistry, but we could name this based on the IUPAC nomenclature that we went over in the last couple of lessons. And we would look carefully at that, and we'd see the parent is propane, and the side chain is a methyl group, and we could call this methyl propane. But be aware, these two examples, because they have the same molecular formula, they will be isomers of butane. So let's see what that molecular formula is. It is C4H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. Both of these have that same molecular formula. A quick look at the structural isomers for N-butane using our ball and stick model would be useful here. And maybe I'll move this out of the way so you might have a better view. This is N-butane. So while it's not truly a perfect straight chain, right, a little bit of angles here, it is considered N-butane, straight chain version. And here was that isobutane, also known as methyl propane. We have the same molecular formula for these two, but you will see we've got a carbon coming off, and this is that methyl group coming off of the propane. Let's look at another example of an isomer. And in this case, we're looking at 3 isomers for pentane. Here is N-pentane. It's 5 carbon, straight chain. It is N-pentane. Okay. The other examples here, we have a carbon that can come off methyl group, a methyl group coming off of this 4 carbon backbone. And our traditional naming for this, we would call this 2-methyl butane. Well, look at this. We also have another 5 carbon isomer. And in this case, you have the parent propane, and you have a methyl group and another methyl group coming off of that parent, we're going to call that dimethylpropane. And all of these have the same molecular formula, which is C5H12. I had to count that up for you, right? C5H12, all of them contain that same molecular formula. Okay, now we're going to move on to a quick introduction into organic compounds containing elements in addition to carbon and hydrogen. So as a reminder, all organic compounds have at minimum carbon and hydrogen associated with them. But there are a number of organic compounds that have other elements. Like in this case, you have an oxygen here, okay? And those are going to be organic compounds that we will talk about, and you will need Table R for this part of the lesson. This will identify certain functional groups that we need to be aware of. Okay, so please make sure you have Table R out. I've blown this up to make it look a little larger for you, hopefully to see better, but it would be very valuable for you to have this for yourselves out. Okay, so we're going to start at the top of the table, Table R, and these are organic functional groups, and you will note that there are a number of classes of compounds. So we're going to look at the first three very quickly here. We will be spending more time in future lessons on these different classes. The functional groups are in the second column, the general formula, and then finally one specific example here. This is an extremely valuable table for you because if you can understand the information given to you in this table, you will be able to really identify any organic compound that you would be presented with by just carefully comparing it to the examples given here. So we've got halides or halocarbons. As a reminder, right, we have halogens, here they are. And whenever there is a halogen associated with a hydrocarbon backbone, you have a halocarbon. So R represents the hydrocarbon backbone to which one of the halogens, X, is attached to or bonded to. And here is a specific example. I did want to point out these examples are known as condensed formulas. Okay, so we've learned a number of different types of formulas in our study of chemistry, and I'm introducing a new name for a formula that is called a condensed formula. And the value of condensed formulas is it separates out the carbons a bit, in this case a halogen, to allow you to see the different groupings of elements in these larger molecules. Again, we will be looking more closely at these in upcoming lessons. A quick look at the next three classes: aldehydes, the ketones, and organic acids. You'll see they have functional groups involving oxygen and double bonded oxygen to a carbon atom. And then the third set of organic compounds with functional groups would be esters, amines, and amides. And again, you'll see these specific, unique functional groups associated with them. So once we get to the amines and amides, you're going to have nitrogen associated with those compounds. Okay, that concludes this mini lesson, and I look forward to studying the functional groups in greater depth in upcoming lessons. Have a great day, folks. Bye.